3 less than 9, so this is the same thing as less than 8, but we're going to stay away from the calculator. We're going to do the algebraic approach, like how can we solve things algebraically. Okay, so a lot of times with these questions, it's nice to have them in standard form, because standard form you can see your min or max right now, right? It's the Q value. You just have to know, is it a min or a max? Okay, you know your axis symmetry right now in standard form. You just have to know, is it P or Q? It's P, okay, opposite of what you see. So anyway, the chord of the vertex here is PQ. Okay, again, you can put opposite of what you see for P if you want this number. Remember, it's opposite of what's there. But that's what the minus kind of tells you. When A is greater than 0, nope, sorry, less than 0. When A is less than 0, so it's a negative, we have a maximum value is Q. When A is greater than 0, we have a minimum value of Q. So remember, this number here, when that number is positive, your parabola is going up. We have a minimum. That's the situation. When your A is less than 0, it's a negative, so your parabola is doing this. We have a maximum. It's just Q, yeah, whatever that number is, yeah. So if it's -3, it's -3, yeah. And your axis symmetry is always x equals P, or the opposite of P, what you see. I just put P because it might be a 3, but you guys know to flip. So you can put -P if that's better for you. Okay, so then max and min applications. So this lesson there tended to be completed algebraically, so we're not using our calculator for these. So consider the following information taken from lesson 8, page 347, class example 1. The height in meters above the ground of a projectile at any time in t seconds is launched by the following equation. Complete the square to write in standard form. So we're going to complete the square on this guy so we can see things a little bit easier. So what we're going to do is we're just going to go ahead and do our normal work. We're going to go -4t squared, little review of lesson 5. Okay, we got plus 48t plus box plus 3. What's the first step? Not quite. The -4 out. Right, Britton? Take -4 out? Yeah. Okay. Whoops, I took a -4 out, so that was positive. This is negative now. Okay. Plus 3. Now we have. The half of -12 is -6. 36 goes there. We have to do 36 times -4, which is a pretty big number. So that's going to be a little bit harder. It's 144. It's a -144 by multiplying, so I have to balance a -144 with a positive 144. Because it's 36 times negative is a negative number. So we've created a negative number, so to balance it, we have to do the positive. We usually subtract because it's usually positive. So you always do the opposite of what these two numbers give you. Always the opposite to balance. Okay, so now we shrink it down. We're done. We have it in standard form. It is y equals -4 times, they have t's, sorry, t minus 6 squared plus 147. Okay, so the things that we can pick up from this, if it says find the height of the projectile at 3 seconds after launch, we still just put 3 in here. 3 minus 6 is -3. 9. Plug in 3 in here if you're not following me. 3 minus 6 is -3. -3 squared is 9. -4 is -36. So it's -36 plus 147. That's going to give me 111. Yep. Okay, these are answers we got from before, so they should look familiar. Find the maximum height reached. We know what that is. 147. It's Q. How many seconds till it reaches that? 6. Tells you right there. What was the height at the launch? How do we find that? 0 for t. So we go 36, which I would just come back to here if I was you. It's going to be 3. You're going to get, you would get 36 times -4. That's going to be 143. 4. Yeah. Okay. We got a couple more questions here at the bottom. So, based on the stuff we have, what would we use to find, without your calculator, what would you do to figure out when it hits the ground? Right? Make y 0. Okay, so make y 0. I'm going to stay with our general form because why? If we can factor it, let's see if we can. You can kind of tell right away you can't because look, negative 4 times 3 is negative 12. 48, that's way too big. Quadratic formula. Got to go quadratic formula. That's your checklist. Can I factor? No. Quadratic formula. Okay, so we got negative b, so negative 48 plus or minus 48 squared minus 4 times negative 4 times 3 all over 2 times negative 4. So we're going to calculate that. When you simplify that inside, the inside simplified is going to give you 2352 all over negative 8. And now you can just calculate that. Negative 48 plus root 2352, negative 48 minus 2352 minus 8. So you do it twice, right, for the plus and for the minus. Okay, when you do that, you're going to get negative 0.1, and you're going to get 12.1, which we know we reject that one because we don't have negative time. So 12.1 is when it hits the ground. For the calculation part, right, but it doesn't want, in terms of the other stuff, like it'll say, you can't complete this, like the calculator won't help you complete the square, right? And it'd be weird to me if you completed the square and had it in standard form and then use your calculator to find the max, because it's right there, okay? But yeah, you have to use your calculator for this part. I would say, Kale, though, on a test, what I would probably do is I'd say you can leave it in exact form. That'd be an answer, just leave it there. Okay, compare the answers from B through F. They're the same. That's all you need to know. They're the same. Okay. All right, we've got this page, and then the last page we're going to skim through a little bit because we're not going to talk about it too much. Okay, this is a common problem people struggle with. Okay, it's the box problem where you have 300 meters of fencing with which form a rectangular corral, enclosed confining livestock. So you're making a fence. One of those sides is an existing wall, so we're not using one of the lengths, for example, which does not require fencing. If two sides of the rectangle are x meters length, and the corral can be expressed as area equals 300x minus 2x squared, okay, show that the area could be that. So we're trying to show where this came from. So let's draw the picture real quick here on the side. So we have a wall, and we're building a fence off the wall like so. Now they told us to put x's here. Now here's the tricky part. What do we use to express this side? No. $300, yes, but not the second part. So here's how you think about it. How much fencing do we have? 300. So this side has to be 300 minus 2x. It's 300 minus 2x. That's what it has to be. That's what's left. We know there's 300 available. We know we're calling these sides x. So this side's 300 minus what these are. Right? So that looks a little bit easier. So now you can see the area is these two multiplied, length times width. And so we just proved that's where the area formula came from. Okay, that looks a lot harder than it is, right? Okay. Use the method of completing the square to determine the maximum area possible. So we're going to complete the square and figure out what's the max area. Okay. So we're going to go ahead and write it with the x squared in front if you're not sure what's happening. Okay, here's our area equation is negative 2x squared plus 300x, right? There's no constant. That's okay. We don't have to move out anything. We're going to complete the square. So we're not going to solve for x. We're going to complete the square so we get in standard form we can see the max or min. So the first thing I'm going to do is pull out a -2.
Why did you flip the...
Just because when we're doing it, we like to have x squareds in front. That's the only reason why. And so now we half it, square it, right? Half of 150 is 75, so -75 squared. We put in the box. Okay, that's going to be, it's a very big number. Yeah, it's going to be, is it 5, 6, 25? Yeah. No.
Yeah, oh no. That'd be 5, 6, 25.
Right here? Okay.
Or it could just... Yeah, 5, 6, 25.
Okay. So 5, 6, 25. Oh, I see. Okay. So then 2 of them. Yeah. Okay. Okay. So 5, 6, 25 is here. So we have to times that by -2, right? Which means we put a plus. Out here is going to be plus what? Nope, 2 of them. 2 of them, right? Times it by 2. So now we're done. It's a of x equals -2x minus 75 squared plus 11250. The only thing you need to know, that is your max area. That's the maximum possible area. So how did I get from there to there? So remember,
How is the
5625? That's what this squared is. Yeah. So that goes there. We take this number, we times it by -2. We did the opposite of that, which was it'd be a -11250. So we added 11250, which is our maximum. Okay. So what is, here's the question. We shouldn't have to do any math for this. What is the value at which gets me that maximum? 75. Right? This is my P, this is my Q. So at 75 length, so what that means is this right here, 75. 75, 75. So what's this side? This side's going to be 150. Because 300 minus 75 times 2, which 75 times 2 is 150. 300 minus 150 is 150. So the dimensions of your rectangle that get you that max area is a 75 by 150. Okay, any questions of that? This won't be on the cumulative, but this does come up again. Okay? All right, so I'll run through it one more time. See, some of you guys are just saying, I'll get this later, but you probably won't. Okay, so we have, again, they told us the area. They told us the area is 300x minus 2x squared. They told us that's the area. So then what we're going to do is we're going to go ahead and figure out how they got that. They got that from, they said the sides are x's. That means that the long side's 300 minus the 2 x's. Remember, we're only doing 3 sides because the 4th side is not fence. That's the wall. So then we completed the square. From this, we put the x squared in front. We completed the square. Got it to look like this. And this tells us at 75 for x, the maximum is 11,250 for area. And then we go from there. Okay? So we plugged x 75 in for x, and that picked up, but that's 150. All right, last one for this page. Okay, Ashley was asked by our math teacher to find 2 numbers which differ by 8 and whose product is a minimum. So 2 numbers that differ by 8 and product is a minimum. So that means you're going to have, the way you put that in words, which people get confused, the larger number is going to be 8 more, right? So we're going to say x represents a smaller number. So it's going to be x times x plus 8. That's what that's saying. X represents a smaller number. Write a quadratic expression for x, the product of the 2 numbers that are 8 apart. So that's it, right? Ashley was asked by our math teacher to find two numbers which differ by 8 and whose product is a minimum. So there's going to be a lot of options. Okay, but in this case, what's the quadratic? The quadratic is this, x squared plus 8x. So it wants us to complete the square on that to figure out what the minimum is going to be. So this one's nice because we'll just do it right here. We just go plus box. We have nothing to pull out. It's just half of 8 is 4, 16. So yeah, that's gonna be the answer essentially. Whoops. So the completed square form is going to be x plus 4 squared minus 16. Yeah, because there's a plus here, we're going to minus it here. So your minimum is negative 16. So if the minimum product is negative 16, what two numbers give you that? That's the tricky part. 4 and negative 4. So what that means is the two numbers 8 apart, okay? The minimum number you can get for multiplying those type of two numbers is negative 16. So for example, let's just change this. Let's move it to 5, negative 3 and 5, right? Those are 8 apart. What's negative 3 times 5? 15, not the smallest. And then we'd keep getting bigger as we kept moving down. So if you took something simple, it's not, not going to be the minimum. 8 times 0, that's not good, right? 0, okay. 7 times negative 1, right? Or 7 times 15. You're obviously just going to keep getting bigger. We're looking for the minimum. That's the minimum. Okay, cool. Last things here. These are just a couple of little, I'll just show you, just they're little, this might help you with your project. This came up in your project. I think Gabby actually asked me this. So like negative b over 2a in general form gets you the x value for your vertex. Negative b over 2a gets you the x value for vertex. And that comes from, what do these kind of look like? They're actually coming from quadratic formula. Okay? They're coming from the quadratic formula, so they do give you these values. So these are just like little, I'd say, extra formulas to get your vertex in general form. Okay? In general form. Okay? All right. Okay, so let's just do this real quick. We'll just do it. We'll use that form up there real quick. This one's vertex is easy. Vertex is negative 5 and 8, opposite of the positive 5, and then the 8's normal. It says it wants us to roughly graph it. Is this one a min or a max? A min. It's a min at 8. The graph looks like 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8. And so it's actually going to be here and going up. That's what it looks like roughly. We'll use the above notes to do this one. We won't complete the square, just we'll practice using what they showed us. This is an extension, so this won't be on the test for this part, but it's just another shorthand way of doing it. So the vertex negative b is negative 12 over 2a, which is negative 4. So 3 is my x value for my vertex. Negative over negative. So negative, negative is a positive. Okay, next piece was said 4ac minus b squared. 4ac, so 4, negative 2, negative 13, minus b squared, so that's 144, all over the 4a of negative 2. Just got to simplify that. So we got negative 8 times negative 13, so that's a positive. What's that, 104? Okay, so 104 minus 144 over negative 8. So we have negative 40 over negative 8. So we got 5. So your vertex is 3, 5. And that picture would roughly look like, well, actually, is this a min or a max? Negative, right? So max at 5, because it's going downward. So So it would roughly look like this. So 3, 5, 1, 2, 3, 1, 2, 3, 4, 5. Right there, like that. It's going down like that. Okay. All right, that's all for lesson 9.